Hello, we are Team 10. This is our senior design project. It is a personal high-rise fire escape system. It was completed by Alexis, Mia, Donovan, Pat, and Johnathan with the help of advisors Dr. Damu and Dr. Eftekhari.
The problem to be addressed is that in the case of a fire in a high-rise building, physically handicapped individuals do not have a quick way out of the building. The purpose of this project is to provide an alternative way, stairs, to evacuate a person in case of a fire. The reason this is important is because it gives an option for handicapped people who may not be able to take the stairs.
The engineering parameters or constraints for the initial design for the high-rise personal escape system were to first be able to support the weight of a single individual, to second, it must be able to both raise and lower the rope or wire down the entire length of the structure, and it also must not ruin the aesthetic of the building. This also must be designed with the engineering code of ethics in mind.
Energy calculations, power calculations, horsepower calculations, and Ohm's law were all used in order to pick out the right motor for this application, which ended up being an AC induction motor. Torque was also used in this consideration, as well as in the gearbox consideration with the gear ratio. Digital logic was also used to make the circuitry.
The electrical portion of this project consists of 2 relays, 2 transistors, and a couple of buttons. This creates a NOT and an AND gate that assure that neither of the motors are on at the same time. The motor is plugged into the wall to receive 120 volts AC. It's an induction motor.
The gearbox in this design is used in order to slow down the motor rather than produce more torque. The gearbox seen in this image is what was used for the initial prototype, but there's also a worm gearbox in production. Designing the prototype taught us to use time efficiently and pick design components that are helpful. We started with the idea of regenerative braking, but soon found that it was not worth the time in this application. We also learned that measuring accurately is very important in our 3D design components due to the amount of time it takes to reprint them. Ability to meet regularly and communicate efficiently helped to develop a working prototype for our group. Lastly, the mechanical engineers were able to delegate work between 3 people in order to produce more components in a faster time frame.
Future design iterations include a washing machine motor, a worm gear to change the direction of the shaft rotation and to decrease speed and increase torque, the design of a new pulley to support and withstand the weight of a person, the addition of sensors, buttons separated from the breadboard for each floor, and a PCB.
Our plans for Senior Design 2 are to remake the 3D printed components, to make the measurements more precise, and also to make the actual device run smoother than the prototype. We plan to explore different materials to use for harnesses such as hemp, nylon, and polyester. We plan to design a PCB and also finalize the design for the gearbox.